This is quiz 9, and in this problem, the first problem, you were supposed to estimate the derivatives that were indicated from the graph that was drawn, and I tried to sketch the graphs again. So the first problem involves, half a dozen or so questions. What's the derivative at -3? So if you go to -3, which is about here, then it looks to me like we are a little to the left of the horizontal tangent line. I think the horizontal tangent line, the way it looks on the original paper, was supposed to be right around -2. So when you're at x equal to -3, you're on the way down looking at it from left to right, but it's not very steep. So I would call this slope about -0.5. But negative anything would be good as long as it's consistent with what the other answers are. So this is something less than a 45-degree angle, so I would call it -0.5 or anything like that. At -2, this was supposed to be a horizontal tangent line. Now, it doesn't look like it too much from the picture that I've drawn here, but if you look at the graph on the exam paper itself and the quiz paper itself, at -2, it does look like the grid mark right there is pretty good as far as the tangent line. So it is horizontal, so I would call that 0. At -1, the curve is on an upswing, and you notice that it's much steeper than that is in the positive direction. This looks to me like a 45-degree angle, so I would call it a slope 1. But, I can't argue with you if it's a little more or a little less than that. But it's certainly not 0, and it's certainly not negative. F prime at 0, well, looking at the picture now, F prime at 0, I guess I would call that 1. And at -1, the way the picture is drawn, now that I look at it, at -1, it doesn't look quite as steep. So really the picture here should be more like this, and it gets steeper as it comes in towards there. And then it tapers off like that. So at -1, it's more like this, so the tangent line would be more like that rather than at a 45-degree angle. So I would call this maybe a half, or maybe, I don't know. If you call this 1, which I guess you would call it 1 because it's more than this is. So if you call this 1, then f prime at 0 would have to be bigger than that, and you might call that 2. Anyway, they're relative to each other because all you were asked to do is to estimate these derivatives. It's not like you had to actually accurately calculate them and pull out your ruler and measure or something. So it's just relative to one another. Okay, the derivative at 1 looks like on the original picture it's at a 45-degree angle. This may not look quite like it, but I would call it 1. And f prime at 2 is where it looks pretty horizontal. The tangent line is 0 in slope. And at 3, it's going down, but again, it's going down about the same as this one was, so I call it -0.5. Okay, so that's about it for number 1. Number 2, you were supposed to construct the derivative from the graph of this original function here on the left. So as I suggested, you probably should start at the horizontal tangents. So here's a place right down here where you've got a horizontal tangent. So at this particular x value, which would correspond to about there, right, you're going to have a 0 derivative. So if this is your graph of f, then the graph of f prime is going to have a 0 value right here. And you'll have a 0 value right here too, because you've got a horizontal tangent line there. So the derivative will be 0, and the derivative will be 0 here. So you're going to have 3 reference points where your graph has a y value for the derivative of 0 at these 3 places where you have horizontal tangent lines. Okay, now moving from left to right, here the graph is going down, and your tangent lines are all negatively sloped. They're fairly steep here, and then as you get in close, the tangent lines are getting not quite so steep, and then eventually they become 0. So it looks like you're going from a very negative number all the way to 0. So I don't know what the slope is going to be, but I'll just draw it like that. It goes to 0. Then from this point, where you have a horizontal tangent line, which corresponds to here, your derivatives are going to be positive, and they will be positive, 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 until they get back to 0 here. So they start off at weakly positive, just very slightly positive. Then they become much more positive, and then they come back to being slightly positive and 0. So that sounds like it's going to go like this. Then here, as you cross over, the tangent lines are going to be negative. Negative, negative, more negative, more negative, more negative, more negative, and then less negative, less negative, less negative, back to 0. So what that means is that the graph is going to be negative, more negative, less negative, less negative, then goes back to 0. And then from here on out, all the graph is positively sloped, going up. So the derivatives are all positive numbers. So I would draw something like that. So that's the graph of the derivative of that function. And then finally, the third example. Now these were all straight line segments on the original quiz paper. Here the line segment is going down, so the derivative is going to be negative. So it's going to be negative, some negative value, but if you estimate the slope of this negative number relative to the slope of this positive number here, this negative is maybe like -0.5, whereas this is like -1. So I would draw a y value down here, and its constant slope until you get to this point right there. And at this point you don't have a derivative. There is no tangent line, because from the left your tangent lines are going to be like this, and from the right your tangent lines are going like that, and they don't come together. So this point is a cusp, and it has no derivative. It has a derivative from the left and it has a derivative from the right, but they don't match up. So there is no derivative value right there. And you can tell that what's happening as you move across from here, these x values, across to this x value, you suddenly have a positive sloped derivative. And it's steeper than this is going down. This is steeper going up than that is going down. So I would draw something starting up here, and it goes all the way to there when something might happen. And you don't have a y value there either. At this point, the derivative is going to change from positive to steeply negative. So just as far as this one is up, we go down to there and continue in the negative direction for a while until we get to here, which would be at this x value. And at this x value, we stop with our negative derivative. So we end up with a hole, because, again, at this point, there's no derivative. The slope from the left and the slope from the right don't hook up. It doesn't curve. It comes to a point. So you don't have a tangent. But on the right, you have a positively sloped, but not as steep as this guy is. So I would come up to here and proceed on straight across, because it's a line, and so the line has constant slope, so that means that the derivative is constantly whatever this number is. And this is the graph of the derivative in the third problem. That's it for quiz number 9.